This is the fourth section of chapter 5 on straight line graphs. And this section is all about length and area. Now we can use Pythagoras to help us to find the distance or the length between any two coordinates. Let's say I've got a line like this between 2 points. And they could be any 2 points. Let's call them x1, y1, and the other point x2, y2. I can think of this as the hypotenuse to this triangle here. I can use the coordinates to work out the lengths of the sides. So the length of this side here would be the difference between y1 and y2. So actually it would be y2 minus y1. And down at the bottom here, the distance between those x coordinates will be x2 minus x1. So that means that this length here, using Pythagoras, is this squared plus this squared, and then square rooted. So the distance between 2 points, and we're using D to stand for distance, x1, y1 and x2, y2 is given by this expression. So basically Pythagoras. Now on some questions it may be more useful to work out the distance squared when you square both sides. But they would be on more problem solving questions where maybe you need to work out the value of one of these coordinates here. Example 13, find the distance between these coordinates here. Okay, so it's easy enough. So let's call this x1, y1, x2, y2. So they just can go into the formula. So D, our distance, is the square root of x2, 5 minus 2 x1 squared. Now this could be the other way around, because when you square it, you're still going to get the same answer. So if I had done 2 minus 5 squared, I'm still going to get the same result, not cubed, squared. And then for the second bit, we're going to have plus y2, 7 minus 3 squared. And again, this could be as 3 minus 7, because once you square it, you're going to get the same result. Right, so let's work out what this is. So 5 minus 2 is 3, so you're going to have 3 squared. 7 minus 3 is 4, so you get 4 squared. I recognise that. Square root of 9 plus 16 is square root 25. So that distance is going to be 5. Now there are no units on this question, so we just leave it as the number 5. Example 14, we've got a straight line L1 with this equation, straight line L2 with a different equation, and it intersects at the point A. And the first part of this question says work out the coordinates of A. So this means we need to substitute one of these equations into the other. Now since I've got a y there, it's going to be easy to make y the subject and substitute that into the second equation. So I've got 4x minus y equals 0. That will give me y equals 4x. That's easy to substitute into the second equation. So I'll have 2x plus 3 times by y, which is 4x, minus 21 equals 0. So that will give me 2x plus 12x equals 21. That's 14x equals 21. X equals 21 over 14. And that can be simplified down to x equals 3 over 2. Divide top and bottom by 7. So that's the x coordinate of A. We now want to work out the y coordinate of A. So let's just substitute it into this. Okay, so let's just write down here x coord of A. So let's now find the y coordinate of A. So y is going to be 4 times by x, which we worked out to be 3 over 2. So y equals 12 over 2, so y equals 6. That means that the coordinate of A is 3 over 2, 6. Moving on to part B, work out the area of the triangle AOB, where B is the point where L2 meets the x-axis. Now this is where a sketch might be useful. Okay, so here's our axis here, like this. We've got these two lines, L1 and L2. We've worked out that they intersect at this point 3 over 2, 6. So maybe let's put 3 over 2, 6, like this. That's the point A. Another point of the triangle is the origin, O there. Okay, so let's just fill that in like that. And we need to find the point B, and that's where the line L2 meets the x-axis. So let's just label that as B. So then let's work that out. So the line L2, so we'll just put where L2 meets the x-axis. That will be when y equals 0. So we'll take the line L2 and we'll make y equal to 0. So that will give us 2x plus 3 times 0 minus 21 equals 0. That's basically 2x equals 21. So x equals 21 over 2. So that's the coordinate value here, 21 over 2. So we've got a triangle like this. Now we know the base and we know the height. The base of this triangle is going to be the length from 0 to 21 over 2. So the length of the base is just 21 over 2. The height of the triangle, perpendicular to the base, distance from the base, which is 6. And we just use half base times height. So area of AOB equals half base times height. And that gives us an exact answer of 63 over 2 square units. Now we could leave that as mixed number or improper fraction, as a decimal, so 31.5 or 31.5. You should now be able to do exercise 5G on pages 102 to 103 of the textbook.